We've done vertical stretches, which are the ones that are in front of the F, or you can move them over and they're with the Y, right? We're also going to be doing horizontal stretches, which are with the X, which is the only thing we haven't done. So a stretch is a transformation that changes the size and the shape of the graph. The original and the new graph are not congruent. They don't look the same because you're going to stretch them either wider or narrower, right? There are two types of stretches. There's vertical, which we've looked at already in grade 11, and then horizontal, which we do now. Vertical stretches are in the form y equals a f of x, okay, where a stretches the graph vertically by a factor of a. If I moved it over with the y, I could go 1 over a equals f of x. And it would be with the y, right? I'd have y 1 over a, or I could go 1 over ay like this. When it's with the variable, we always do the opposite, right? That's what we've said the whole time. So when it was with the x, and it was x minus 3, we moved 3 to the right, correct? We did the opposite. Same thing with stretches. If it's with the y, you actually do the opposite. So you would stretch vertically by a factor of a over 1. So it'd be a. It would flip, okay? So when it's with the variable, you always do the opposite, including stretches. When it's not with the variable, you keep it. So if we always move it over to here, we can always just say it's vertically stretched by a factor of a, which is what we've always done in grade 11 and so on. But with our horizontal stretches are going to be with the variable always. You can't get them away from it. They're in a bracket ultimately with that x no matter what. Okay? So what do our vertical stretches do? They stretch our y. So we're going to multiply our y's by it. What we've done so far is we've multiplied our x's or y's by -1s if we had a reflection on them, and we'd add to them or subtract from them if we moved up or down or left or right, correct? Vertical stretches just multiply the variable by it. So if we have vertical stretch by vertically by a factor of a, we're going to do x is going to stay the same, and my y is going to be multiplied by a. The points are invariant on the x-axis. Why would that be? If I had a graph like this, why are these points not going to change? Why are they going to remain the same, which means invariant? This point here, let's say it's 2, 0. Why would it stay 2, 0? Our mapping is xy. It becomes xay. So we're technically keeping the x the same. This would stay at 2. And then we're multiplying this by something, right? When you multiply 0 by something, what does it stay? 0. So the invariant points are on the x-axis when we only have a vertical stretch. Remember, if we have any transformations on top of this, then we can move them around. If we move them around and stretch them, then they're not going to remain invariant on the x-axis. The only time they remain invariant on the x-axis is if we have a vertical stretch or a reflection in the x-axis. The moment we put on a vertical translation, it's going to shift them up or down, and it'll change it. Okay? So it's when we have just this stretch that these will remain the same, because the y value is 0, and if I multiply 0 by anything, it stays the same. Okay? If a has a negative sign of it in front of it, then it's a reflection in the x-axis. So then my point would actually become, if it was y equals -a f of x, like this, my xy would become x negative ay. So you would just multiply with the negative as well. That's all that would happen. And these would still remain invariant, because if I multiplied this by a negative value, it would still stay 0. The only way this wouldn't remain invariant is if I put a vertical translation on it, because then it would shove it up or down, right? So if there's a vertical stretch or a reflection in the x-axis, your invariant points are going to be on the x-axis. So let's look at this graph. Describe the transformations that occurred if the original graph of y equals -4 f of x was y equals f of x. So what's happened? That -4 in front, what does that cause us to have? We did this in grade 11. We do stretches, reflections, translations, right? So do we have a stretch? Yes, if it's in front. We have a vertical stretch by a factor of 4. Do we ever say negative for our stretches? Does the negative change the stretch at all? No, the negative just causes the reflection, so we never put the negative in. So vertical stretch by factor 4 about what? The x-axis. So vertical stretch by a factor of 4 about the x-axis. Because remember, we always just take that value, whatever it is. And then what does that negative cause us to have? A reflection in the what? X-axis. Because when it's with that, you always say the opposite axis, right? So it has a reflection in the x-axis. If I did mapping, my point xy would become x. My x would stay the same because nothing happened to my x. It's still just in the brackets by itself. And my y would become negative 4y. So I would just multiply all my y's by negative 4 and keep my x's the same. Given the graph of y equals f of x, use a table to sketch y equals 2 f of x. So what am I doing? I'm going to move a graph. The moment I want to move a graph, I have to use mapping, right? Moving points, moving a graph, I use mapping. So my original xy, my x stays the same because nothing happened to my x, right? It was just an x, still just an x, nothing changed. My y has multiplied by 2. Is it negative 2? Is there a negative here? No, so it's just 2. So my x is going to stay the same because nothing happened to it, and my y is going to be multiplied by 2 because I have a vertical stretch by a factor of 2 about the x-axis. So all I'm going to do is keep my x's and multiply my y's by 2. So this is the original points, these 4 original points just plotted here. So my x is negative 2. It's going to stay negative 2. My y is 0. It's going to be multiplied by 2, and it stays 0. Why does it stay 0? Because 2 times 0 is 0. So those are my invariants, right? They're not changing. So this one's not going to change, and this one's not going to change as well. That 4, 0 is going to stay 4, 0. Negative 1, 2. Negative 1 stays the same. And then we're going to multiply the 2 by 2. So it's going to be 4. So we're at negative 1 and 4 now. And then our x stays the same, 0. And our 5 gets multiplied by 2. So now we're at 0 and 10. Does that look like the graph has been stretched by vertically by a factor of 2? Doubled vertically. Does it look like it? Yeah. So remember, same thing. When you're moving points or you're moving a graph, you use mapping. Always, always, always. Example 3. Graph y equals x squared, then replace y with 3y. So we're replacing y with 3y. We're doing replacement notation. So y becomes 3y. So we take the y in y equals x squared. We take this y, we huck it out, and we replace it with 3y. Most people don't like the vertical stretch with the y. They like moving it over to the other side and leaving everything in y equals always. That's usually the choice. So I would divide by 3. When I divide by 3, how can I write that so I actually have it in front of the x squared and it's a vertical stretch? 1 over 3, because there's technically a 1 right here, correct? And I can just bring it out front. So I can go 1/3 x squared. So what is that? A vertical stretch. Is it with the x? Or if it's with the x, a lot of people think this one's with the x. If it was with the x, you guys, it would have to be in brackets like this. There would have to be brackets out like this. Because right now, the only thing that's squared is just that x, right? You can't, if the 1/3 was squared, there'd have to be a bracket out there to tell you it's joined in with it, and it's not. Okay? So it is a vertical stretch. By a factor of 1/3, you just keep it about the x-axis. Now this question wants us to graph it on the same axis. the graph of y equals x squared, and then the new one. The graph of y equals x squared is 0, 0, because if I plug a 0 squared is 0, 1 and 1, negative 1 and 1, 2 and 4, negative 2 and 4. Because if you plug them in, say I plug in a 1, 1 squared is 1, so that's why it's 1 and 1. If I plug in negative 1 here, negative 1 squared is 1, 1 and 1. If I plug in a 2, 2 squared is 4, negative 2 squared is 4. So that's how you get it. You could also go y equals x squared into your y equals, and then grab your table of values off your calculator as well. You can do that. So that's our original. We want our new. So what are we going to do? We're going to do mapping. We're moving points. So our x, y becomes x. X stays the same because nothing happened to our x. And our y is stretched by a third. So we're going to multiply by what? 1/3. So my x stays the same and my y is multiplied by a third. So this point is going to remain at 0, 0 because 1/3 times 0 is 0. So if I go 1, 1, it's going to become 1 and 1/3 times 1. So it's going to become 1 and 1/3. Oh, goodness. Then if I do 1 and negative 1, or negative 1 and 1, sorry, it's going to become negative 1 and then 1/3 times 1. So it's negative 1 and 1/3. And then this is 2 and 4. What's 4 times a third? 4/3, right? 4/3 is 1.33333. So it's just going to move down to here. Okay, so if we plug in negative 1 into x, the square root of negative 1 doesn't exist. So no negatives can go in here, so there is no graph on the left of 0. If I plug a 0 into here, the square root of 0 is 0. So my first point is at 0, 0, 0. I plug in a 1, my second point is at 1, 1. I plug in a 2, it'd be at root 2. That's harder to do, correct? So I like picking like full square roots. So I go to 4. Square root of 4 is 2. And then I pick 9 after that because the square root of 9 is 3. You can do decimals in between. It's just easier if you don't choose decimals. So that's the original y equals square root x graph. And it has points at 0, 0, 1, 1, 4, 2, 9, 3. So mapping says I'm going to fill that in. I'm going to go 1/2 y equals square root x. And to get rid of a half, what can I multiply by? 2. So I'm going to get y equals 2 root x. So it's a vertical stretch by a factor of 2 about the x-axis. It's about the x-axis because it affects the y variable. So my x's are going to stay the same and my y's are all going to be multiplied by 2, right? So this point's going to stay here 0, 0. Because it's invariant, because it doesn't change. Because if I plug 0 and I multiply it by 2, I get 0. So it's going to become x and 2y. So 0, 0 is going to stay the same. This is going to be 1, and then this can be 1 times 2, which is 2. This is going to stay 4, and then this can be 2 times 2, which is 4. It's going to say 9, and then 3 times 2, which is 6. So my new points are at 0, 0, 1 and 2, 4 and 4, and 9 and 6. So your x's are going to stay the same and your y's are just multiplied by 2. So it's vertically stretching it by a factor of 2. Then we deal with horizontal stretches. Horizontal stretches are in the form y equals f b of x. Now, this is with the x, right? When it was with the x and it was x minus 2, we said it was 2 to the right. If the b is with the x, which will always be, your horizontal stretch is actually by a factor of 1 over b. So the point, you could just do this 1 over bx, y. You could write it like that as well. So the b stretches the graph by a factor of 1 over b. And it should have here about the y-axis. Because when it's with the x, it's about the y-axis. So this time the points on the y-axis are invariant because you're multiplying all your x's by a number. And your x's on the y-axis are 0. So it's the same thing. And then if b has a negative sign in front of it, it's a reflection in the y-axis. So that's where we get that other reflection, right? If there's that negative with the x, then you have a reflection in the y. The only catch here is that that b flips. The b flips just like the x, you said the opposite, right? It's the same thing. So describe the transformations that occurred to the original graph if y equals f of 5x was y equals f of x before. So because it's with the x, it's a horizontal stretch by a factor of what? If it's a 5 beside the x, what's it going to be? That's 5 over 1. So what's that flipped? 1 over 5. About the y-axis. So remember, if it's with the variable, you flip it. You flip the sign when it was a translation. You flip the actual fraction when it's a stretch. So horizontal stretches always flip because you can't move it away from the x ever. So here we have that stretch, but now it's with the 2, or it's a 2 with the x. So this would be a horizontal stretch by a factor of what, guys? Not 2, 1/2. About the y-axis. So we're going to move points. If we're moving points, we're doing mapping. So this is x, y. It's going to become x. Is it x still this time? It's affecting the x, right? So what's it going to be? 1/2 x. And my y stays the same. Because nothing affected my y's. There was nothing outside, right, that changed. So my y's are going to all stay the same. And my x's are going to be multiplied by 1/2. So it's going to be negative 2 times 1/2 is actually negative 1. And then my y stays the same. Negative 1 times 1/2 is negative 1/2. And then my y stays the same. 0 times 1/2 is 0. It didn't change because they're invariant. And then 5. And then 4 times 1/2 is 2. And then the 0 stays the same. And then we plot our points. So negative 1 and 0. Negative 1/2 and 2. 0 and 5 stays the same. And then 2, 0. So it is narrower, which makes sense, right? I horizontally stretched it by a factor of 1/2. It should be 1/2. Okay, you guys try this one. Okay, once again, when we plot x squared, it's 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. Now we want to replace x with 2x, so we're going to get y equals 2x squared. Now, if you watch yourself on this one, this could also be a vertical stretch. You could either say this is a horizontal stretch by a factor of 1/2 about the y-axis, which I'll show you because this is how everyone did it. xy is going to become 1/2 x and then y. So every one of my x is going to be halved. So this will stay here. This will move here to negative 1/2 1 here. And the 2 becomes a 1. And this becomes a 1. And it goes like this. Right? The catch with the squared and only with the squared, and because this one doesn't have an f in it, is I can actually expand it out. If it had an f in it, I'd be done. But because it doesn't have an f in it, I can expand that out, and I would get y equals 4x squared, you guys. Now, is it with the x? No, I got it out of the x. It's not in the brackets anymore. I distributed it. So this is going to be a vertical stretch by a factor of 1/4 about the x-axis. Now, this is the only case where this can happen. It can't have an f, it has to be a squared, and it can be written like this. But it does pop out every so often that they do this to you. Now, people will say, but then it doesn't give me the same thing. Actually, it does. Your mapping for this one would be xy will become x. Oh, it's not a quarter, people. It's not a quarter. What is it? 4. It doesn't change, right? It's not with the y. If it was with the y, it'd be a quarter over here, and then we flip it to 4. So it's 4. And it's going to become 4y. This is actually the same. Your x's stay the same, and my y's are multiplied by 4. So let's see if this works. Well, this would stay the same, be 0, 0. What would this become? It's at 1, 1. It would now be at 1, 4. Be right here. You'd get the exact same graph. Exact same graph. It wouldn't change the graph at all. The catch is that they'll say, list the transformations of this equation, and the transformation you want to say is horizontal stretch by a factor of 1/2, but they actually have vertical stretch by a factor of 4. Okay? Only for this case. If they had an f in here, it would change the whole ordeal, because then we wouldn't know exactly what the graph was, and they wouldn't have the squared. They only do this squared when it's by itself, just like this, and then they do that. That's the only one where they switch it from vertical to horizontal, horizontal to vertical. Okay? So, let's look at example 5. Describe the transformations. Remember when we describe transformations, you guys, we describe the transformations that only of what has changed from the original to the new, correct? So, the original was 4 minus x cubed. I see a 4 here. Does that mean it went down or anything like that? Or up by 4, or there's a reflection or any of that stuff? No, this is the exact same. This hasn't changed. Neither has this changed. All that changed is I have a 3 in front. So I can distribute the 3 in if I want to the whole thing and then state my whatever's happened. So if I distribute the 3 in, you'd have to watch what happens. You have to change it. So we'd get y equals 12 minus 3x cubed. Would we distribute it in, though? Would we? Could we? Should we? What would we do? Do we have to distribute that 3 in? Does it affect the 4? Yes. So if you have an originally transformed graph and you're applying a stretch to it, that stretch applies to the whole entire side. The whole entire side. You have to apply it to the whole thing. So what happens? This is actually a vertical stretch by a factor of 3, right? And then you're 12. So you have to watch when you do your when you apply a vertical stretch, it affects the vertical translation as well. Does this cause any issues? This 2 in here? Does it affect the y? Does it affect the translation? No. So this would be a horizontal stretch by a factor of what? A half, a half, a half, a half. Your horizontal stretches always flip, always flip, always flip. If you move everything to the one side, to the right-hand side, your vertical stretches stay, your horizontal stretches flip. If you always get it into y equals. Okay? So this is where it starts, where we start combining them. So let's look at this. Describe the transformations that occurred if the original function was y equals x squared. So basic function. I don't have any vertical translations, anything on it, just basic function. So what's changed? This -2 in front and this 3. Okay, so let's start with stretches, then reflections, then translations. Are there any stretches? Are there any numbers sitting out in front? Yes, this 2. So this is a vertical stretch because it's not with the x. If it's with the x, it would be in brackets, correct? Is it in brackets? No. Vertical stretch by a factor of 2 about the what axis? So it was the opposite axis. So it's affecting the y, so it's going to be about the x-axis. I have a negative in front. I don't put -2 because the negative causes me to have a reflection in the x-axis because it's with the y. T, is that 3 with the x or not with the x? Not with the x. If it was with the x, it would be in with the x. It would be a bracket, and it would be squared, right? So it's not with the x, so it's a vertical translation. 3 what? Up. B. B has a catch. B has a catch. This catch will be on every test, on every cum. It will be on your diploma. I would be shocked if they didn't do it because transformations comes up in every single unit from now till the end. So you need to know your transformations because you're going to transform the whole way through. When you talk about vertical stretches and vertical translations, or horizontal stretches and horizontal translations, you guys, this translation, the only way I can state the translation, remember I told you it has to be x plus something or x minus something, just x plus something or x minus something. Right now it's -2x plus something and x minus something. I have to remember to take that -2 out, or I'm going to list my horizontal translations wrong every single time. And there will be a question like that on your test, on your cum, on your diploma, where they have them together like this, and you have to remember to take that -2 out, because your horizontal translations are only stated when it's x plus something or x minus something. That x has to have a 1 in front of it. Right now it doesn't have a 1 in front of it, so I have to take it out. So I'm going to get y equals bracket -2 x what? When I take a 4 out. When I take a number out, what am I indirectly doing? I'm what operation? Dividing. So I'm going 4 divided by -2 when I take out that GCF. 4 divided by -2 is what? -2. So you guys, even if there's a -1 in front of the x, you have to take it out because I have to have a +1 in front. So for example, if it was like this instead, y equals f -x plus 3, I would still have to remember to take that -1 out. So it would actually be y equals f -1 x minus 3. I'm actually going 3 to the right, not 3 to the left. Do you see how that's an easy oopsie to forget to take that -1 out? Most people remember if it's a number, but if it's a -1, people often forget to take it out. Okay? You need to have a +1x plus something or a +1x minus something in order to tell your translation. Okay, do you see how that's going to be a common error? I would star. I remind you guys like 7,000 times and people still forget it on the test. Okay? It will be on the diploma somewhere. I'd be very shocked if they don't have it where you have to take the horizontal stretch out or a reflection out. Okay? So now, once we've taken that out, we can state the answers. Now, you guys, they're going to have the answer 4 left. They're going to have that answer 4 left, for sure. It's wrong. You will pick it. It will be there, okay? So you can't be like, they'll probably just not have it, so I'll know that I have to. No, they will absolutely have it, and it gets picked all the time. It's not 4 left, it's 2 right, okay? You have to remember that. So I have a stretch. Is this a horizontal stretch or a vertical stretch? This is the fight. People tell me it's not with the X anymore. When you take that out, it's still with the X. The whole thing's still squared, is it not? Yes. When you take that stretch out, it's still with the X. It still flips. Horizontal stretches always flip, always flip. There's not one time ever in the land of 30-1 that your horizontal stretch is never going to flip. It will always flip. So don't be like, well, it's with it or it's not with it. It will always flip, okay? So we have a horizontal stretch by a factor of 1/2 about the y-axis. How did that just happen?
So we kind of disregard the square.
Yeah, because that didn't change. The square didn't change. It was squared here. It's squared here.
Right.
And then we have a reflection in the y-axis. And then we have a horizontal translation. Oops, horizontal translation to right. Common error is going to be 4 left. That answer will be there. The answer to 4 left will be there, whether it's in mapping notation, whether it's replacement notation, whether it's in words. The 4 left will be there. You have to remember to take that -2 out. All right? Example 7. I want you to try this one. About a minute. So for this one, I have to remember to do what? Take out the -1, or I'm going to say it's 3 to the left, and it's not actually 3 to the left, it's 3 to the right. Right? Very common error. You can see easily how you mess that up. So y equals f, take out the -1, x minus 3. It's still with the x, you guys. It's the big ultimate, big brackets keep it with it, right? So is there any stretch? Is there a horizontal stretch at all? No, the -1 just makes it a reflection in the y-axis. Because it's with the x. And you have a horizontal translation 3 right. Okay? I'll give you your homework.